Welcome back, lovely students. We're going to be doing lesson 7 right now, solving general linear equations. And the only difference between this and lesson 6 is that we're going to have fractions and decimals in some of these equations. And so we're just going to learn some tricks for how to get rid of those. But along the lines, we are also going to learn how to classify equations, which is essentially just saying whether it has a solution, has infinitely many solutions, or does not have any at all. Okay, the application we are going to come back to at the end. Your new job at a car dealership offers you $300 per week plus 1/5 of your weekly sales amount over $10,000. How much value would your sales need to equate to in order for you to make $6,000 in 1 week? So we know you're going to get $300 automatically, but then how are we going to get up to that total of $6,000 by selling vehicles? So we'll come back to that one at the end. Getting started here, nice little easy warm up. We are going to have to distribute a couple times today. So just to warm up, go ahead, pause the video, try the warm up on your own. Okay, hopefully you paused. So for number 1, we are going to take this negative sign, distribute it to the a and to this -4. A negative sign times an a. Remember when I say a negative sign, really I mean a -1. So that's going to give us -1a, or I can just write -a. And when I distribute the negative sign to the -4, I'm going to get +4 out of it because those negatives will cancel. 3/2 getting distributed to a 12x and to a 20. When I distribute 3/2 to the 12, 12 is divisible by 2, and it gives me 6. And then 3 times 6 on top will give me 18x. And then 3/2 times 20, again, 20 is divisible by 2. 20/2 is 10, and then times 3 is going to give me 30. Okay, and then down below we have 5 minus, and we're going to distribute this -2 to the n and to the +1. That's going to give me -2n minus 2, and that 5 was still in front. So now we actually do the subtraction. 5 minus 2 gives me 3, and I still have that -2n right next to it. All right, so now general strategies for solving equations. Most equations that we need to solve are going to require the following steps. Okay, we're going to need to simplify both sides of the equation as much as possible. We are going to try to collect the variable terms on one side and the constants on the other. So 2 very key things to start. First is to simplify. Okay, always try to make each side as simple as possible before you get moving. And then the actual strategy for how we solve is we collect variable terms on one side, and on the other side, we collect the constants. Okay, so we're trying to separate those two things because once we have all the variable terms on one side, we put them all together to just have one variable term. And then we will make the coefficient of that variable term 1 by either multiplying by the reciprocal or by dividing whatever's in front of it. All right, and then at the end, we just check our solution, which I will skip the check solution step on most of these. However, when you are taking a test or doing anything where your solution really matters to you, you should always take the time to plug it back in. So for the first one, number 4, I will plug it back in, but then after that, I will stop doing it. But do keep in mind that I went through the time to get a master's degree in mathematics, so I feel like I'm allowed to skip a couple more steps than you guys are allowed to. So now, number 4 here. We want to solve 4 times x plus 5 plus 1 is equal to negative x minus 4. The way I'm going to start is by keeping myself organized. I'm going to draw a vertical line through the equal sign. And what this does is ensure that I work vertically and that I am writing everything evenly. Meaning if I add or subtract something from one side, I'm going to add or subtract it from the other side of that red line also. Before I have to do any of that though, first I just need to distribute. So I have a 4 that's going to get distributed to an x plus 5 and a -1 that's going to get distributed to an x minus 4. So when I do each of those, I get 4x plus 20 and -x plus 4. But I can't forget that I had a +1 on the left side. Okay, so that +1 stayed put. All right, so now I have a couple things that can be combined. On the left, I have a 20 and a 1. So I'm just going to put those together to get 4x plus 21. And the right side stays the same. Now I'm going to start shifting things around, where my goal is to get all of the x terms on the left and all of the constant terms on the right. So I always like to start by moving the x terms. So I'm going to add this x that's on the right to both sides. Because it's a negative x, I add x because that cancels it out from that right side. But whatever I do on the right, this is why I have that red line there, is to remind me to do the same thing on the left. So I went ahead and added x to both sides. What happens here, and I don't know why I didn't zoom in, but what happens here is that negative x and positive x on the right side cancel each other out. They are additive inverses, so I get a 0 there. And then on the left side, 4x plus x is 5x, and I still have this plus 21, and on the other side, I still have a plus 4. Now, before I go on, notice where I wrote things down. X over here, and 4x over x on this side. I do not write this plus x underneath the 21 because I don't add 21 with x. I add 4x with x. So part of staying neat and making sure you're doing things correctly is writing the x terms over the x terms. That way you're always adding together the correct things. Okay, so now moving on. We need to move that positive 21 to the other side. Because it's a positive 21, I will put its additive inverse below, which is negative 21. And notice again on the right side, I write minus 21 directly underneath that 4. These 21s cancel. I am left with 5x is equal to negative 17. And then now the last step in the process is to make the coefficient of 1, or the coefficient of x, be a 1. And in order to accomplish that goal, I multiply both sides by the reciprocal. So what I'm going to do is put 5x in parentheses and put negative 17 in parentheses, multiply both by 1/5. Okay, when I do this, the left side is going to become plain old x, because 1/5 and 5 cancel out to give me a 1 there. And on the right side, negative 17 times 1/5 is just negative 17 over 5. And there's nothing fancy to do with that. Okay, but now, because this is the first one, we're going to actually check if this works. So in order to check, I need to plug in negative 17 over 5 to that equation at the top. So to check my answer, I'm going to do it up here. So we're going to check. Everywhere I see an x in there, I'm going to write a negative 17 over 5. So 4 parentheses, negative 17 over 5 plus 5 plus 1 is equal to negative 17 over 5 minus 4. So now if you're looking at that thinking, hey, that's kind of not the most convenient thing ever to check, I would like to remind you of two things. Number one is that you have a calculator, and you are more than welcome to check your work by plugging in what I just typed to a calculator. But the other one is that you're supposed to be good at fractions, right? Like that's part of what we're learning in this class to practice. And so you can definitely work this out using, or by hand, by working with the fractions. But this is a good chance for me to show you how you would get this done on a calculator. So I'm going to go ahead and go split view with the Desmos calculator here. Okay, and then we're going to be typing in exactly what I had there, and we're going to see if the two things are equal to each other. So on the left side, 4 parentheses, and I need a fraction now, so I'll hit the division symbol. Notice it makes a fraction for me. Negative 17, I hit the arrow to get to the bottom of the fraction, put a 5 there. Go to the right, use the right arrow again to get out of the fraction. Plus 5, parentheses, plus 1, and that gives me 7.4. So now I'm going to hit the blue button to get to a new line. And now I'm going to type in what's on the right side of the equation, which is a negative sign, and then parentheses, fraction, negative 17 over 5, minus 4, and then close the parentheses. And see on the right side of the screen how we have two 7.4s over there, meaning that both sides came out to 7.4, so we do get an equal number on both sides. All right, so in this check step here, I can just write that I got 7.4 equals 7.4, and that tells me again that what I did was correct, okay? Negative 17 over 5 is in fact the solution. All right, now number 5. We have distribution on both sides, but before I worry about any of that, I always start drawing a line. I want to stay organized every time I do these questions. Okay, organization's key. Now I'm going to distribute a negative 3 and a negative 5 on each side here. So we're going to get negative 3x plus 21, because negative 3 times negative 7 gives me a positive. Then on the right side, negative 5x plus 30. Again, negative 5 and negative 6. I get a positive there. And I can't forget that there was a negative 4 on the left this whole time. Now I'm going to combine like terms on the left side. So negative 3x plus 17 is 21 minus 4. The right side's going to stay the same. And now I start moving around x terms. Okay, I prefer to always get the x's on the left. However, that's not required. You could put them on the right. But for sake of consistency, I always like to move them to the left. So in order to move the 5x that's over here on the right to the other side, I can't literally move it. So instead what we do is we add it to both sides. So I'm going to do plus 5x and plus 5x. That is going to cancel out the 5x's on the right. And on the left side, negative 3x plus 5x is positive 2x. Then I still have a 17 and a positive 30 out here. So now I need to move the 17 over. It's a positive 17, so I do minus 17. Go ahead and simplify. The 17s cancel. I'm left with 2x on the left and 13 on the right. And then I want to get the x coefficient to be a 1. So I'm going to either, you could think of it as division by 2, but I just prefer to think of it as multiplying by the reciprocal every time. So on both sides, I'm going to multiply by 1/2 because that is the reciprocal of 2. So now on the left side, I get plain old x by itself. That's how I know I'm done. And on the right side, 13 over 2. I could also write 6.5 there, but 13 over 2 is just as good. And you could take the time, plug that back in for x, verify that this is in fact the solution. But I'm going to leave that as a little task for you to do. Okay, so now, if you have not stopped the video yet and tried some of these by yourself, now is the time because you have all the skills to do what I'm about to do. So take a second, try it out, give yourself a chance. Okay, hopefully you have paused, attempted, and now you're back in it. So we're going to focus in on number 6. I'm going to draw a long red line because this is going to take quite a few steps. And now we're going to start distributing. The key is to follow order of operations here. We need to start with the innermost parentheses. So on the left side, there's no confusion. There's only one set of parentheses. I'll just do that distribution there. But on the right side, I can't distribute this 3 yet. Well, I can, actually. But instead, we're going to start with the innermost set of parentheses, which would be this 4 distributing to the negative 1 and the negative 4 end. To be clear, what my little chuckle was about, if you do distribute this 3, it would go to that 3 and that 4. That actually is perfectly acceptable. But we haven't really had much of a chance in this class to talk about how to distribute something that has parentheses inside. So for sake of not confusing anybody, I will not do it that way. Instead, I'm going to distribute that 4, which is the innermost one. So on the left, we're going to get positive 9n plus 9. And on the right, when we distribute that 4, we'll get negative 4 minus 16n, where I still have the rest of the problem around it. 56n plus 3, parentheses, 3 minus, and then negative 4 minus 16n. All right, so now we're in a better spot. Inside of those parentheses on the right, I'm going to go ahead and combine like terms. So if you look closely, we have a 3 minus 4 right here. I'm just going to put those together to be a negative 1 in this step. So my left side is going to stay exactly the same, but on the right side, I'm going to take 3 minus 4 and write a negative 1 in its place. Okay, so all I did was right here, 3 minus 4 became negative 1, and then now I'm going to distribute this 3 into this set of parentheses. So on the right side, I'm still going to have 9n plus 9. That was the left side, and on the right side, I'm going to have 56n plus, and then when I do this distribution, I notice that I'm going to do 3 times negative 1 to get negative 3. So that addition symbol I wrote, I actually don't need. I'm going to put negative 3 there. And 3 times negative 16 is going to be negative 48. And there's an n on that one. Okay, now we can still combine, do a little bit more simplification. The 9n plus 9 stays the same. But on the right side, 56n minus 48n is going to give me positive 8n. and I still have that minus 3 there. Okay, now we're going to go ahead and start moving things around. So to do this, I will subtract 8n from both sides to get all the n's to the left side. So that 8n cancels out on the right. I want to do that in green. 8n cancels out. And on the left side, we have 1n plus 9 is equal to negative 3. I'm going to then subtract 9 from both sides. So now on the left side, those 9's cancel. And all I'm left with is n is equal to negative 12. And then at the bottom, I like to just rewrite it, n equals negative 12, just so that way it's separate from all that work I just did. Lots of steps in that one, but notice that everything up top here, everything that was messy, was just combining like terms, just simplifying, doing a little distribution, had nothing to do with the equation solving. Okay, the actual equation solving part is generally not so bad. All of this up here was just simplification. All right, number 7. First things first, vertical line, keep us organized. Okay, now distribution. I'm going to distribute this 4 to the 2n plus 5 to get 8n plus 20. And on the right side, I have 19n, which is just going to stay put. I have a plus 2, which is going to stay put. And then negative 7. And then now I'll start doing this distribution of negative 2 into this set of parentheses is going to give me a minus 2 minus 6n. And then end those parentheses. All right, a little bit of combining like terms. The left side stays exactly the same, 8n plus 20. The right side, 19n plus 2 stays. But inside these parentheses, negative 7 minus 2 gives me a negative 9. All right, and then now in this next step, I can go ahead and distribute a 2. Okay, notice very repetitive process, right? Just distribute, combine like terms. Distribute, combine like terms. So when I distribute this 2, I'm going to get negative 18 minus 12n, and I still have a 19n in front and an 8n plus 20 on the other side. Now we're going to combine like terms again. So we have 8n plus 20 on the left is going to be equal to now 19n minus 12n is 7n, and we still have that negative 18 there. And now we can finally start actually equation solving. Okay, all of that was just to get it into simplest form, so now we can move things from left to right. Okay, all that just simplification. Now we're going to actually take these 7n's, move them to the other side. So minus 7n from both sides. On the right side, they cancel by design because they're additive inverses. On the left side, we get 1n plus 20. And on the right side, just negative 18. We can go ahead and subtract 20 from both sides. And what we are left with is that n on the left, these 20's cancel, is equal to negative 38. And so n is in fact negative 38. And ooh-wee, that was a lot of steps. But hey, not so bad. All right, let's go ahead and keep going. So now we can take a little bit of a back seat. Okay, we're going to slow down just a bit. This is review to get us ready for what we're about to deal with fractions and multiplying by powers of 10. So at first, we want to evaluate 8 times 3 over 8. Not meant to be complicated here. Hopefully you look at it and go, oh, 8 on top, 8 on bottom. Those cancel out. This is just 3. Okay, not so bad at all. Number 9, in the unfortunate case where we do not have common denominators, what we're going to have to do is find the lowest common denominator, which for this problem is going to be a 12, because the least common multiple of 6 and 4 is 12. So now, if I want to turn 5 over 6 into something over 12, 6 times 2 is 12, so on top I do 5 times 2, which will give me 10. And for the other one, 4 times 3 is 12, so 1 times 3 on top gives me 3. Add these together, and I get 13 over 12. Okay, now multiplying by a power of 10, when it's a 100, that is 10 to the power 2. Okay, so remember 100 equals 10 to the power 2, and it's this exponent here, this 2, that tells me I'm moving the decimal place twice to the right. So 4.78 times 100 is just equal to 478, where all I do is move that decimal place twice to the side, in this case to the right. Okay, so you can either look at the number of zeros on the 100 or the fact that it's 10 to the power 2, and that 2 is what tells us 2 decimal spots to the right. Okay, so now you're thinking to yourself, what if we have fractions as coefficients? Can we just like get rid of those? And the answer was, well, yeah, kind of. Like that's pretty much exactly what we can do. So when dealing with real world problems, we're often going to have equations that involve fractions. And to clear, quote unquote, clear the fractions in an equation, we'll multiply both sides of the equation by the lowest common denominator. And that'll be the lowest common denominator for all fractions we see. And when the equations involve grouping symbols, a lot of times it'll be necessary to clear fractions twice. It says C number 7. It should actually say right there C number 14, which is going to be on the next slide. When I say necessary, by the way, necessary is maybe an exaggeration. Okay, so I'm going to write kind of here. You can definitely multiply by something that will get rid of all of the fractions at once, but personally, okay, like my own personal preference when I am solving the problems is to just ignore fractions that are inside of parentheses until I've gotten them out of those parentheses. I'm not necessarily saying this is actually easier, but I find it makes more sense when I'm doing the work myself, and so I like to teach you guys how to do it in the same way that I would do it. Okay, but we'll get to that in a second. Right now, number 11, we have two options for how we can solve this, okay? We could go straight to the answer by multiplying both sides by the reciprocal of 3/4. So I could go directly to multiplying both sides by 4 over 3, like so, and that will give me x is equal to 3 times 4 over 3 is just going to be 4, and I can get x that way. Okay, perfectly good, nothing wrong with that. By the way, that red line would have been there that whole time. I just forgot for a second. But alternatively, because this is what we're going to do in the next couple problems, you could instead, so if we restart this thing, 3 over 4x is equal to 3. Instead of trying to go directly to the answer like we just did, you might want to just get rid of the fraction first. And so in order to get rid of the fraction, notice it's a 4 in the denominator. I can multiply both sides by 4. Okay, when I do that, on the left side, those 4's are going to cancel. One's on top, one's on bottom. So I get 3x. And on the right side, I get 12. And then, now that I have 3x equals 12, now I could divide both sides by 3 or multiply both sides by 1/3. And this will get me to the same place I would have been anyway, which is that x is equal to 4. Okay, so whichever method you prefer, one just does it all at once, the other does it in 2 steps. The only reason I show you the second way, which took 2 steps, is because when you have multiple fractions, that's what we're going to do, is we're going to multiply by the lowest common denominator, and then we'll go about solving from there. Okay, because we just don't like fractions. We prefer to get them out of the way as quickly as possible. Okay, number 12 is just a reminder of what to do when you have to combine fractions. Okay, so this run not meant to be challenging. Hopefully, we're comfortable adding and subtracting fractions. But x plus 1/5, I got to do the same thing that I would do if it just said x plus 5, which is subtract that number from both sides. And when I do that, luckily these are both over 5, so I have a common denominator. So on the left they cancel by design, and on the right side we have negative 4 over 5 minus 1 over 5. That's going to be negative 5 over 5. And so in my answer I can reduce that to just be negative 1. Alright, so that one, not meant to be challenging, just meant to remind you that if it is a fraction, remember that a fraction is just a number. So you do the exact same thing you would do if it said x plus 5, which is subtract 5 from both sides. Okay, so we treat fractions no different than other numbers. Alright, so now more practice. This is where multiplying both sides by the lowest common denominator is going to come into play. So for the 13, we're going to multiply both sides by 16. And for 14, we're going to multiply both sides by 3. And then we're going to have to multiply both sides again in a later step. But I tell you that now, so go ahead and pause the video. That way you can take a chance at it. Okay, hopefully you pause. So now coming back in here, vertical red line, keep me organized. And what I'm going to do is multiply everything here by the lowest common multiple, which is going to be the LCD, because we're talking about denominators, least common denominator. But it's the lowest common multiple of 8, 4, and 16. Okay, and in this case, 8 and 4 both divide 16, so this is just going to be equal to 16. If you are ever unsure of what the least common multiple is, I encourage you to just multiply by one of the denominators, whatever the smallest one is, okay? Or, well, really, any of them. Choose any of the denominators and just multiply the whole equation by that. And then some stuff will cancel and the problem will become easier in the next step, okay? So even if you didn't know that 16 was the right number, if you multiplied everything by 4, or multiplied everything by 8, or multiplied everything by 16, all of those are going to get you to a better, more simplified place. So just pick a denominator and work with it, but it is best if you go directly to the least common multiple of the denominators, because then you only have to do this once. Okay, so all that said, we're going to multiply the whole left side by 16 and the whole right side by 16. On the left, 16 times 3 over 8. Notice that 16 is divisible by 8. It gives me 2, and 2 times 3 on top will give me 6, and so this will be 6x. And then 16 times negative 1/4 is negative 4. Okay, if you need to do that scratch work on the side, by all means. When I did 16 times 3 over 8, what I really did is 8 times 2 times 3 over 8, where notice the 8 times 2 is on top, that's the 16. These 8's canceled, and then 2 times 3 is what I was left with, which gave me that 6. Okay, so if you ever need to do that scratch work on the side, by all means. All right, and then on the right side of this thing, 1/16 times 16, those 16's cancel, so we just get 1. Now, nice easy problem like before, I can go ahead and add 4 to both sides. The 4's on the left cancel, so I am left with 6x is equal to 5. Then we can go ahead and multiply both sides by 1/6, which is the same as dividing both sides by 6. And when I do that, I'm going to get an x on the left and a 5 over 6 on the right. So x equals 5 over 6 is my solution. Okay, so the key there was to multiply everything by the least common denominator of the fractions, which was 16. Once you get rid of those fractions, that takes us to this step here, and then it's exactly like the other problems we've solved, nice and easy. Okay, number 14. So now what I was hinting at before is that I prefer to just ignore this fraction 5 over 6. I pretend that one just doesn't exist because my goal is to just get rid of this 1/3 first. Now, you could definitely do it in one fewer step than what I'm going to do, and so that's totally fine if you want to do it that way. You're going to see that we're going to multiply by 2 later, and that'll get rid of the second fraction. So you can go straight to doing that. But I prefer to just focus on the outer fractions because, I don't know, it just works a little bit better in my mind, to be honest with you. So I'm going to multiply everything here by 3 because I know that that 3 is going to cancel out this 1/3 in the front. And then on the right side, I'm going to multiply everything by 3 also because I got to do the same thing on both sides. Okay, when I do that, on the left, the 3 canceled out the 1/3, and I just have 2x minus 5 over 6 left. And on the right side, negative 3. So now, technically, I could just add 5 over 6 to both sides, and there's nothing wrong with that. That's perfectly fine. But then I'm going to have to find a common denominator with the 3, and I don't really want to do that. So instead, I can clear that fraction also by now just multiplying everything by 6. Okay, so notice I got rid of the 1/3 by multiplying by 3. Now I'm going to get rid of the 6 on the denominator by multiplying everything on both sides by that denominator, which is 6. Okay, so now when I distribute that 6, I'm going to get 6 times 2x is 12x. 6 times negative 5 over 6 is just negative 5 because the 6 is canceled. And then negative 3 times 6 is a negative 18 on the other side. Notice, by the way, that had I multiplied by 18 at the beginning, which is 6 times 3, I could have skipped all of this, or I could have skipped that second step, I should say. But I don't think that that's actually all that much faster. I think it's easier to just get rid of the 1/3 first and then get rid of the 6 in the denominator after. All right, but no matter how you got here, now we're at a point where we just need to solve for x. So we can go ahead and add 5 to both sides. That's going to leave us with a 12x all by itself on the left because those 5's cancel. So 12x is equal to negative 13. And then I'm going to go ahead and multiply by a 1/12 because that's the reciprocal of 12. I'm going to continue my red line a bit to keep things neat and clean. And then what I'm left with is an x on the left side and a negative 13 over 12 on the right side. So x equals negative 13 over 12 is my solution. All right, hey, those two down. Now we're moving on to decimals. The key there to dealing with fractions, remember, is to just multiply everything by the lowest common denominator of the fractions you see. Okay, just clear those fractions and then it becomes a nice, easy problem. So now, even though this is technically a different slide, it's really the same slide. Because when we are dealing with real-world problems, just like before with fractions, we might have decimals, and we clear decimals actually in the exact same way we clear fractions because, well, they are fractions, they're just represented in decimal form. So what I mean by that is the power of 10 we're going to multiply by is going to be based on however many decimal places we want to get rid of. So if we want to get rid of one decimal place on this 1.5, I would have to multiply by 10 to do that. But if I want to get rid of two decimal places on this 0.88, I have to multiply by 10 to the power 2, which is 100. And same thing, two decimal places on the 0.62 times 100. So overall, times 100 is what I'm going to do. But let me show you what that looks like as fractions real quick to make it very, very clear as to why. In my opinion, very clear. 1.5x, well, 1.5 is 1 and 5/10. So we can rewrite this as 15/10 over x, or times x. 0.88 is actually 88 hundredths, so that's 88 over 100. And 0.62 is actually 62 hundredths. And so now notice when I write them in fraction form, we're going to multiply by the lowest common denominator of 10, 100, and 100, which is just 100, okay? So it's the exact number we would have multiplied by in the beginning to move it two decimal places everywhere, okay? But the reason it works out that way is because that's the same thing we would do if they were in fraction form. So by multiplying everything here by 100, on the left side, 100 divided by 10 is 10, and 10 times 15 is going to give me 150. So I have 150x. 100 times 88 over 100 is just 88. And on the right side, 100 times 62 over 100 is just 62. All right, so we now have a nice easy equation again where there is no decimal places, no fractions. All we have to do now is go ahead and move 88 to the other side. When I subtract that 88 from both sides, it cancels out on the left because they're additive inverses. So I have 150x is equal to, on the other side, whenever it's a small number minus a big number, remember, just flip it around. Do 88 minus 62, which is going to give me a 6 there and a 2 there, so I get 26. But it's negative 26 because the 88 was negative. Okay, so negative 26 because the 88 was the negative one. All right, then we're going to multiply both sides by 1 over 150, because that's the reciprocal of 150. But remember that you could also just divide by 150, same thing. So when we do this now, we're going to have x all alone on the left. And on the right side, if I just continue this red line down just a bit, we have negative 26 over 150. And now I got to think about if this can reduce at all, which it definitely can. Okay, so I have x equals, and then instead of writing it as 26 over 150, I'm going to try to break this down into factors. So I know 26 is 13 times 2, so 2 times 13. So now when I break down 150, the only things that I care about trying to divide it by are those two factors on top, 2 and 13. So I know that 150 is 2 times 75. And since 13 doesn't go into 75, I know that if I just cancel out these 2's right here, then I'm going to have my reduced fraction. So x is going to be equal to negative 13 over 75. If by chance we had something divisible by 13 on bottom, we would be able to keep going, but 75 is not divisible by 13. All right, so that's how you get rid of decimals. Notice that me writing it as fractions was completely unnecessary. So let's go ahead and try to do it without writing it as fractions. So this time around, vertical red line. The most decimal places I see is 2. Because on the right side over here, I have 20.26, 2 decimal places there. There's also 2 decimal places on the 0.86 there, but then everywhere else I only see 1 decimal place. So I'm going to multiply by 100 on both sides because I see 2 decimal places as the most places. When I distribute this 100, it goes to this 1.2 in front and to this negative 1.86, but it does not go to the 1.7x or the 1.6. Okay, this piece here is attached to the 1.2. This is all one term here because it's multiplied together by that 1.2 is being multiplied by both things on the inside of the parentheses. So when we distribute, we only distribute to the front, not to all 3 things. All right, so now when we actually work that out, 100 times 1.2 is 120. The parentheses, like I said, are going to stay the same. And then negative 1.86, when we multiply by 100, is negative 186. And on the other side, both those decimal places are going to drop off, so we have 2026. Okay, now, I would like to do some distribution here, where I have a 120, and I have a 1.7 on the inside. Okay, so now we got to think a little bit. I'm multiplying 120 times 1.7. 120 was actually just 12 times 10. So that 10 factor is going to end up getting rid of these decimal places. I don't really need to know that in advance, but it doesn't hurt to know that when I multiply 120 times 1.7, because of this 0 on the end of the 120, I know that it's something times 10, and that 10 is going to cancel out the decimal in the 1.7. Okay, that being said, in order to do this, I can either whip out a calculator or I'm going to do a little scratch work on the side. 120 times 1.7. When I do this multiplication, I just kind of ignore the decimal place at the beginning. So I multiply the 7 times everything, carry 1, we get 8 there, and then multiply the 1 times everything, so 0, 0, 2, 1, add them up, 0, 4, 10, carry 1, 2. And then because I had 1 decimal place in this problem, I have 1 decimal place in my answer. So 204.0, where I have to throw that decimal place in there, that one right there, because I had 1 decimal place in my problem. So 1 decimal place also shows up in my answer. So 120 times 1.7x is going to be 204 times x. And then now I got to do 120 times 1.6. So again, on the side, do a little scratch work, where I'll multiply that 6 times everything. Oops, I keep carrying too many numbers there. So 0, 0, 2, 1, add them up, 0, 2, 9, 1. So I get 192, and again, 1 decimal place in there because I had 1 decimal in my problem. So plus 192. And then I still have this minus 186 from above and a 2026 on the other side. Now I'm going to have to go ahead and combine like terms on the left. So the 204x stays alone, but 192 minus 186, that's a difference of 6. So I can say plus 6 here. 2026 on the other side. Now, nice easy solving steps. I'm going to subtract 6 from both sides. That's going to leave me with just the 204x on the left because the 6's are additive inverses. They cancel. On the right side, I get 2020. And then now I have to do the actual division. So multiplying both sides by 1 over 204. is the same thing as dividing both sides by 204. So on the left, I'm going to get x all by itself. And on the right side, 2020 divided by 204. Ooh, that's going to be not a clean number because if you look at it, when we start doing that division, 204 is not going to go in to 202. So why not just pull out a calculator real quick, right? This is why we have them. We could do this division by hand. By all means, if you want to, you sharpen your skills. But I'm going to go ahead and pull out my calculator, type in 2020 divided by 204, and that's going to give me 505 over 51. So the reason that it did not look like it was going to divide cleanly is because it doesn't divide cleanly, right? We end up just reducing a fraction to be 505 over 51, which is the same thing as 9.9. And so now we have to decide what's better, okay? Because if I put a decimal answer, I'm going to have to round that decimal, okay, to like 2 decimal places, most likely. Well, usually the problem would specify, by the way, but in this case, I would probably round that to be just 9.9 because the next number is a 0, seems convenient. But here's the thing, if I round it, it's no longer exact, and if I write the fraction, 505 over 51, then it is exact. So the basic rule of thumb is if the problem does not say to round, then you should give the reduced fraction. If it said here, round to the nearest tenth, then go ahead, round it. But because it does not tell me to round, I'm going to leave it as 505 over 51. All right, and then I will put that x is approximately, so wavy equal sign, 9.9. But again, we would prefer the exact answer. Okay, exact is always better. All right, we're